Hi there, my name is Peter. Today I'm going to talk about the cloud solution I've designed for GoGreen company. So let me just share my screen. So practically, the company will have three VPCs for three different purposes: production, develop, and test. The VPCs will be in North California as it is the closest one to the headquarters, which can ensure the lowest latency. Since they're all the same, so I'll just demonstrate the production VPC whose CIDR is this one. So in this VPC, there are four subnets in two availability zones. Each availability zone contains one public subnet and one private subnet. By doing this, the availability and reliability will be ensured, as when the instances in one AZ fails, the instances in the other AZ can still operate. There will be an internet gateway to connect the VPC to the internet. Also, there will be two net gateways. Each of them will allow one private subnet to access to the internet while denying the access from the internet. In the VPC, there will be 5 security groups. So here, therefore, web ELB, web instances, app ELB, app instances, and database instances, respectively. As we can see here, the app security group will allow traffic from port 8080. The other will allow traffic from different ports to ensure the security at the instance level. Now let's look at the instances. Sorry for there's a lot of termination of the instances. These are the experimental ones, but I could only terminate them, but not clear them. So the instances are supposed to use the Red Hat Enterprise AMI for GoGreen. However, due to the limitation of the sandbox, I could only create the AMI T2 micro instances. Yeah, these are all T2 micro instances. As we can see here, there are two instances running for the web tire. One is here and the other one is here. They are in different availability zones in the region. I have implemented the load balancer to make sure that the request will be distributed different instances to be processed to ensure the performance of the system if needed. So here is the load balancer. We have one for web and have one for the application. All right, so here is a web ELB. Let's copy this DNS name and open it. Open here. So from here we can see this is the AZ we're using. If we refresh the page, we can tell that this part is been changing. So because of the load balancer is using different instances to do the request. Also, when there are more requests from the user, the instance will be launched to ensure the performance of the system and reduce the latency. Here is the auto scaling group. We can see that there can be as many as 10 instances to ensure the performance. The app tire will be same as the web tire. So it also has an auto scaling group here for application tire and a load balancer for it as we can see here. This is for the application tire. So as for the database tile, there will be a primary database instance and a secondary database instance. The secondary one will be used for backup and execute the request when the primary one fails. And let's look at the S3 part. Here I created a bucket called GoGreen bucket for the GoGreen company. The application instance can upload and access image once the user uploaded to the S3. So the S3 bucket can store objects in there. And here I created a lifecycle rule for the S3 bucket called move to S3 Glacier. So everything in the bucket, if it's after three months, it'll be moved to the glacier, and then it'll be permanently deleted after 5 years. So if we can see here, which I've done is to translate. So here we can see it'll be transitioned to glacier after 90 days, and then permanently deleted after 1,830 days, which is 5 years. Okay, so lastly, let me introduce the additional components I've implemented, which is the CloudWatch, which can monitoring the EC2 instances. So here I've created an alarm called CPU overused. I will receive the email telling me this information if the CPU is overused by SNS. So let's see in the SNS. Here is a topic called CPU overused. And it was subscribed by my personal email. So my email will receive that information once it is triggered. That's all for my presentation. Thank you for watching.